Hi there, welcome to edupediaworld.com. You're watching the videos on quadrilaterals. So in this video we'll discuss some more examples related to quadrilaterals which are very important from the exam point of view. So you have to watch this video very carefully. Okay, now let's discuss our first example. Example number 1. Now the example number 1 says that two parallel lines L and M are intersected by a transversal P. We need to show that the quadrilateral formed by the bisectors of interior angles is a rectangle. So we need to prove that ABCD is a rectangle. So let's discuss how we can do this now. First of all, we need to write given. It's given that L is parallel to M and P is transversal. Okay, then it's given that the bisectors of the interior angle meet at a point. This means if this is a bisector and this is a bisector, so they meet at a point B and D. So let's discuss how we can prove this. So let's discuss the proof now. It's given that we can say that L is parallel to M, so and P is a transversal, so we can say that angle PAC, this angle, is equals to this angle. Why? Because they are alternative interior angles, equals to angle ACR. So we can write now, since AB is a bisector, AB is bisector of angle PAC, so we can write that angle PAB equals to angle BAC, or we can write that half of angle PAC as angle BAC. So let it be first. Now similarly, angle ACR, it has a bisector CD. For angle ACR has a bisector CD. So same way we can write this angle equals to this angle. So we can write angle ACD is equals to angle DCR, or we can write half of angle ACR equals to angle ACD. We can write right now, if suppose it's given angle PAC equals to angle ACR. Why they were equal? Because they are alternative angles, alternate interior angles. Since L is parallel to M and they are alternate interior angles, so we can also say that half of angle PAC equals to half of angle ACR. Now half of angle PAC is angle BAC and half of angle ACR is angle ACD. So we can say that BAC, means this angle, is equals to this angle. So if these two angles are equal, they form a pair of alternative angles. Now angle BAC and angle ACD form a pair of alternate angles. Then we can say that AB is parallel to CD. Now in a quadrilateral, if one pair of sides are parallel, so then it's a parallelogram. So we can say that ABCD is a parallelogram. Now so we have ABCD as a parallelogram. Now let's see how we can prove it further. Suppose it's given that this line is a straight line, this line is a straight line, so we can write it as angle PAC plus angle, means this angle plus this angle is 180 degree because they are angles on a straight line. So we can write angle PAC and angle SAC or angle CAS, whatever you can write. Let it be S, A and C. This angle equals to 180 degree. We can write. Now since it's given AB is a bisector of angle PAC, so we can write half of angle PAC plus half of angle SAC equals to half of 180 degree. Now, what is half of angle PAC? It is angle BAC. You can write angle BAC plus, now half of angle SAC, we can write angle ACD or CAD. We can write half of angle SAC as angle CAD, which is equals to 90 degree. Now, if you see this angle plus this angle is angle A, you can clearly see that angle BAC plus angle CAD is angle A, means this angle plus this angle is angle A. So we can say that angle A is 90 degree. Now, in a quadrilateral, if one pair of angle is 90 degree and opposite sides are parallel, so then it's a rectangle. So we can say that ABCD is a rectangle. So this is how we can prove that these type of questions. So let's discuss the next example, the example number 2. Now, the example number 2 is very important example from the exam point of view, which I have seen generally coming in examination. So you have to watch this example very carefully. We need to show that the bisectors of angles of a parallelogram form a rectangle. So we need to show that if these are the bisectors and we join them, they form a rectangle. So we need to prove that PQRS is a rectangle. So let's see how we can do this. First of all, we need to write given. It's given that the bisectors of angles of a parallelogram. Now, these are the bisectors and they meet at point PQRS. So we can say that. Now, how we can prove this? Let's say discuss the proof. Now, let's consider triangle ASD first. Now, in triangle ASD, we can say that AP and DR are the bisectors of angles A and angle D respectively, right? So we can say that now angle DAS plus angle ADS can be written as half of angle A plus half of angle D, means DAS. So this is angle DAS, so which is half of angle A because AP is a bisector. Similarly, ADS is half of angle D. Why? Because DR is a bisector. Now we can write angle DAS plus angle ADS equals to, if we take half common out, it will be angle A plus angle D. Now, so this becomes angle DAS plus angle ADS equals to half of, now, angle A plus angle D. If we see properly, angle A plus angle D form a pair of co-interior angles. Why they form a pair of co-interior angles? Because if you see properly, AD is a transversal and these two lines are parallel and AD is a transversal, so they form a pair of co-interior angles. And we also know that angle A plus angle D equals to 180 degree. Why? Because sum of co-interior angles is always equals to 180 degree. So we can put angle A plus angle D as 180 degree. So this will come out to be 90 degree. So we can say that angle DAS plus angle ADS equals to 90 degree. So we have this angle plus this angle as 90 degree. Now, if you consider triangle ASD again, we can see that angle DAS plus angle ADS plus angle DSA equals to 180 degree. Why? We can write angle sum property of triangle, right? So we can write angle DAS plus angle ADS plus angle DSA equals to 180 degree. Now we know that angle DAS plus angle ADS is 90 degree. So we can write 90 plus angle DSA equals to 180 degree, and this implies is angle DSA equals to 180 minus 90. So angle DSA equals to 90 degree. So we have this angle as 90 degree. Now if you see properly, this angle and this angle are vertically opposite angles. So we can say that angle DSA equals to angle PSR. Why? Because they are vertically opposite angles. So we can write angle PSR equals to 90 degree. Right? So this angle is 90 degree. Similarly, if you consider this triangle again BQC, so we can say that now QR and BP are the bisectors. So we can write QCB as half of angle C and QBC as half of angle B. Then again we can prove that angle CQB is 90 degree, and through vertically opposite angle we can prove that this angle is also 90 degree. So same we can prove for the other angles also. So we can say that now that PQRS is a rectangle. Why it's a rectangle? Because if in a quadrilateral all angles are 90 degree, then it's a rectangle. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.